Hi, in this unit we're going to discuss vibration and pull diagnostics. So what causes a vibration on the highway? Improper wheel balance is the most common issue. Sometimes it's a problem with a tire or wheel. Something could be bent or out of round, or you could have a tire with a force variation problem. But there are other things like driveline problems, so like a bent drive shaft or a bad joint or something like that. Engine problems like a misfire are sometimes misinterpreted as a vibration. Transmission problems like torque converter clutch shutters or gear hunting sometimes appear to be a vibration issue as well. So we have a scenario here. We have a rear-wheel drive vehicle with complaint of a vibration and pull on the highway. Customer states that the problems were not present until new tires were installed. So there's been some service done to the vehicle, then the problem occurred. Very often that means the problem is related to the service that was just done. So we suspect the tires. Shop foreman drove the vehicle and confirmed the problem. Note that his test drive, he would have been out trying to duplicate the conditions that the customer said caused the problem. So if the customer said, the vibration occurs at 100 kilometers an hour, the shop foreman would have driven it at 100 kilometers an hour to see what it felt like. He also would have done things like try to shift gears or vary the engine load to try and eliminate some of the other things that might cause something that feels like a vibration. All right, so test drive was done. Shop foreman says, take this thing and I want you to do a road force and straight track wheel balance on the Hunter balancer. Okay, so your professor will tell you what vehicle you're working on. So procedure, part one. As per the worksheet, you're going to label all four of the wheels and tire assemblies, take them to the balance, and you perform the straight track balance. Now, you want to do them in the numbered order, so balance number one first, number two second, etc. The machine will record everything, all the parameters for the balance job. So it'll record, how much pull that wheel or tire might have had, whether it has much road force variation, if it just needs to be balanced, all that kind of stuff. All that data will be recorded, right? Now, you might not have used the balancer in a while, so we've got a little bit of a refresher for you right here.
Now.
Okay. Maybe we don't. There we go.
Force matching is indexing the low spot on the rim with the stiffest part of the tire to get you the best possible ride. Failing assemblies are indicated by the warning pop-up, red rash tire, and red meter. Start the procedure by pressing the button on the outer arm. Follow the on-screen directions as necessary. Place the inner data set arm against the inside rim and place the outer arm against the outer bead seat. The edge on this rim is not conducive to a run-out measurement. Here is a rim that has an accessible measurement area for the outer data set roller. When the outer bead surface is not accessible, start the run-out measurement by pressing the thumb button on the outer arm. Then return it to its home position while keeping the inner arm on the rim throughout the run-out measurement process. Once it is completed, the screen displays force matching results. In this case, the assembly could be improved significantly. To do this, mark the tire at its top dead center position, as shown on the screen. Press the Start button to move the wheel to the next top dead center position, and mark the rim. Now, remove the wheel assembly and take it to a tire changer. On a tire changer equipped with bead rollers, use them to pinch and hold the tire in place and rotate the rim until the marks are aligned. Remove the rollers and reinflate the tire. Then take it back to the wheel balancer. Remount the assembly and recheck tire pressure. Lower the hood to remeasure road force. When it's finished, verify the results and balance the wheel accordingly. In cases where the outer bead seat surface is not accessible, force matching without measuring rim runout will yield the best results. Press the outer dataset arm button, then select Match without rim runout. Verify the tire is inflated to specifications. And then lower the hood to begin the first road force measurement. Next, position the valve stem at top dead center, and then press Enter Valve Stem. The assembly will servo 180 degrees. Mark a V at top dead center. Then press OK. Now remove the wheel assembly from the balancer. Deflate the tire, then break the beads. On this tabletop style tire changer, you may be able to rotate and align the V mark to the valve stem by hand if there is enough bead lubrication. Reinflate the tire and reinstall the assembly on the balancer. Once the wheel is clamped, position the valve stem at top dead center. Then press Enter Valve Stem. Recheck the tire pressure. Lower the hood to remeasure road force. When finished, the balancer will coordinate the optimal position of the tire on the rim. Mark the tire and rim at their top dead center position. Then remove the assembly from the balancer and take it back to the tire changer. Deflate and loosen the beads. Another way to match the marks is to lift the top bead over the rim. Once the tire is loose, rotate it to match the tire mark to the rim mark. Next, remount the top bead. Once together, you may need to adjust the tire to the exact position needed. Reinflate the wheel and reinstall it on the balancer. Recheck the tire pressure. Lower the hood to remeasure road force. Verify the results and balance the wheel accordingly.
Procedure Part 2, perform a match mount or force matching, as Hunter calls it, if it's needed. If it's not needed, record all the wheel and tire data and just continue with a normal balance. After all 4 wheels are done, review the situation with your professor. Once cleared, once we've had our discussion and decided what needs to be done with this, then you're good to reassemble the vehicle. Okay, conclusions. From this procedure, you should be able to decide what exact components are causing the problem on this particular vehicle. But what would you do if you didn't have a road force balancer? So there are options. So if you have a pole, you could inspect the chassis, make sure it's in good condition, there's no obvious problems with it. You want to verify the tire type, size, and tire pressure, look if there's any abnormal wear, anything like that. These are all things that would, cause a pull. Now, as a diagnostic step, you can rotate the tires from side to side. So if we have a vehicle that pulls to the left and we swap the tires from right to left and now it pulls to the right, then we know the tire is a problem. If the pull doesn't change, then likely the tire is not the problem. As far as balance problems go, we would typically take the tires off and just check them for balance on the balancer again, even on a standard balancer. You can rotate the tires from front to rear. Sometimes this will help solve the problem. If you feel a vibration but it's kind of vague, can't tell where it's coming from, you rotate the tires from front to rear, and now you see it in the steering wheel. It's an indication that the tires that are now on the front are the ones that are causing the problem. Now, if you've gone through all these steps and your vibration is still present, you can't find any faults with the wheels and tires, you've checked runouts on everything, the wheels and tires, then you can start looking at the hubs and things like that to find out if there's a problem in the vehicle chassis. Okay, that's it. See you in class.